Hello children, in a previous class we discussed what is thrust, what is the pressure and which factors does the pressure depends and the related concepts, even applications also we have discussed. And let us see the today agenda. Dear children, in today's class we will discuss a pressure related to the fluids. There we will discuss what is the pressure exerted by the liquid column. Then we discuss loss of liquid pressure, and finally we discuss the consequences of the fluid pressure.
Pressure in fluids. So children, first let us discuss this point. So in a previous class we discussed already what is a pressure. Before going to discuss how pressure is exerted by a fluid, children, let us understand what actually fluid is. Children, this term is very important to understand. Very important to understand. Now let us compare with the solid and let us make a difference. You may get a one doubt actually. Sir, in this topic, what is the need of understanding the difference between solid and fluids? Yes, there is a difference. There is a difference. First, let us see the arrangement of the molecules. In a solid, dear children, do you think that the molecules, that is atoms, are moving here and there? No chance. They are fixed in their positions. But whereas in the fluids, it is not like that. The atoms are not so tightly bound, so that they have that freedom to move. Okay. So in fluids means, children, we have gases, that is liquids, again gases. This is very important. Children, the main difference between solid and a fluid is that in a solids, atoms, they do not move. Okay. Whereas in a fluids, they will move. This is very important. Means if it is in the case of liquids, means the atoms of the liquid will move in a vessel or throughout the liquid they will move. So in a gases, they will have more freedom. They have more freedom. So this is a basic difference between solid and a fluid. Children, here one important point. Can the solid flow? Yes, so it's a bit funny here, right? You know, it's the question is, you know, we feel like it's, sir, does it sense anything? Of course. So first you should understand that move, when you can say that a substance can move, you know, the whole body should be displaced. The whole body. For example, here is a pen. Okay, I can say that yes. Now this pen is moving, whole body is moving. Okay. Can you say that river is moving, water is moving? No, we can't say that, because entire river cannot move. Entire thing won't happen at the same time. There we can say that river is flowing, water is flowing. So how to define fluid, dear children? The substance which can flow is called fluid. It's very important. Children, what is a fluid? It's very important to understand. It's easy also. What is a fluid, children? The substance which can flow is called fluid. Now, in today's topic, we will be discussing, can fluid exert pressure? If so, in how many directions it can exert pressure? Before that, let us one more point discuss regarding the solids. In last class, we discussed that solids can exert pressure. Yes, but in how many directions? Let us see, children, here. Here is, let us take a surface. On this horizontal surface, here is an object is placed. Okay. So every object has a mass, children. As every object has a mass, due to the force of gravity, it has some weight. Children, in the case of solid, especially in this case, in which direction does the weight act? Undoubtedly downward direction. So this weight will be acting in downward direction. Am I right? Yes. This weight is acting downward direction. Where it is acting? On the surface where it is placed. On the surface where it is placed. Means, can I say that weight is nothing but the force? Yes. Weight is a force with which an object is pulled by the gravity. Yes, we can say that. Means here, some force is acting on the surface where solid is placed. This force, if you can calculate per unit area, yes, then you get a pressure. Then you get a pressure. So, as force is acting downward direction, yes, on certain area, we can say that solid exerts pressure. But in what direction? Undoubtedly, it is a downward direction. It is downwards only. Children, is there any chance where solid can exert a force upward direction or a sideway? No chance. So, we can conclude that solids exerts pressure only in one direction, that is downwards. Of course, solid exert pressure on the surface where it has been placed. Now, the point is that can fluid exert pressure is a point. Children, let us see, it's very important. It's very important. So, children, again I repeat, solids can exert pressure downward direction on the surfaces where it has been placed. Okay, fine. Children, here, let me take a container. Let me take, here is one container. Okay. In this container, okay, it's, let us say, surface area is A, this area, sorry, area of that bottom of the vessel, and here liquid is taken. Children, can the, see, and one more thing here, let me tell you, through the chapter, of course, fluids only, but especially in fluids, we'll be talking about only liquids only. Okay, don't get confused there. So, now onwards, we'll be using liquids. Okay, fine. So, here liquid is taken, that's no problem, fine. Children, don't you think that liquid has some mass? Yes, liquid has a mass. Every atom of the liquid has a mass. Okay, fine. Let us consider one liquid atom. I'm talking about one liquid atom. So, obviously, don't you think that there will be some force of gravity on this atom? Yes. In which direction? Downward direction. That force of gravity only we can call it the weight. Means what? Each and every atom exerts some force on the, what we can say, bottom of the vessel in which it has been taken. Like this, children, each and every atom, due to their weight, exerts some force on the surface of the bottom. Am I clear? It's very, very important. Sorry, area of the bottom. Area of the bottom in which it is taken. Means what? Entire liquid exerts force on this area. Right? So, whenever force is acting on an area, definitely there will be a pressure. There will be a pressure. So, can we say that liquid exerts pressure in a downward direction? Yes. What is the reason? Because of its weight, children. So, liquid exerts pressure in downward direction due to its weight. It's very clear. It's very clear. So, similarity is that here solids exert pressure downward direction. Yes, liquid also exert pressure downward direction. Okay, fine. Let us move a little bit forward. Children, in a solids, atoms, they do not move. It's clear. But do you think that the atoms in a liquid will stay at a fixed positions? No, it is not like that. They will be moving randomly. So, let me take a, for example, here, let us take one atom. So, this atom can move in this direction, right? Yes. Of course, it is not fixed. It has to go like this only. It can be randomly, it is moving. Randomly, it is moving. Children, let us think this, my whiteboard is the wall of the container. Wall of the container. Let us take, try to understand. Here is my fist. Okay, it is one atom. Then what will happen? It is going and it is striking. So, like this, you imagine all the atoms of the liquid, as they are moving randomly, they will be hitting the walls of the container in which the liquid is taken. So, don't you think, means they will be having some collisions with that walls of the container. So, during the collisions, what will happen? Some force is exerted. Some force is exerted. So, that force, if you can calculate per this force which is acting, if you can calculate per area, per unit area, then you will get the pressure. So which means what? It also very clear that liquid exert pressure on the walls of the container in which it is taken. So they can exert pressure in sideway also. Clear? Fine. And here let us take one more atom. Let us take one more atom. Children, it is not compulsory that this atom should go only right side. It is not that they will be moving randomly. But to understand, to make the concept simple, just we are choosing the atom and we are understanding. Okay, fine. So let us take this atom is moving upward direction. Yes, definitely all atoms are four. Means as they are moving randomly, they also can move vertical upwards. So then obviously when you can consider some surface area here, definitely what will happen, there will be exerting force on the surface. The best example, children, whenever you will try to immerse, any football, any tennis ball, then what will happen, children? As long as you keep your force on that ball, then only what will happen, it is remain under the water. The moment when you can take out, what happened? It comes to the water surface as if somebody is hiding inside the water and they are pushing vertical upwards. Isn't it? Yes. But is someone there? No, it's not that. Then who is exerting force? That is a liquid. So here liquid can exert force and force vertically upwards. Of course, for this force only special name is given buoyant force, which will be discussed in upthrust. Okay, fine. So as the liquid exerting force vertical upwards, if you can consider some area here also, if you can consider some area, yes, you will get the pressure. So children, it's very clear that here, it's very, very clear. So liquids are exerting the pressure downward direction, in sideway also, vertically upwards also. So with this, what can we conclude? Liquids exert pressure in all directions. So this is a important point, important conclusion of this discussion. Okay. So from this, in examination point of view, how can we expect the question? Children, question can be asked like this. Solids can exert the pressure, liquids also exert the pressure. But how does it differ? Pressure exerted by the solid from the liquids. Okay. What should be the answer? Solids exerts pressure in downward directions on the surface where it is placed. Only in one direction, that to downward direction. But what about liquids? Liquids exert pressure in all directions. So these are important conclusions. Am I clear? Fine. Okay. So children, so it's very clear that liquids can exert pressure in all directions. Okay, fine. Now let us try to calculate the pressure exerted by the liquid column. For example, children, we have taken some liquid in a container. Let us take a container. Then how much pressure is exerted by that liquid? On which factor does it depend? You may get one doubt. Sir, why to learn? Why to understand the pressure exerted by the liquid taken in a small container? Yes. What we will do, children? We will discuss for a small container and we will apply for big things in order to understand why walls of the dam made thicker at the bottom only. Why air bubble formed at the bottom of the pond as it raises its size, what we can increases. So those things, the application part, everything, even submarine concept also based on this only. Okay, na? So let us understand for small things, let us implement for big things. So always our learning process should be from simple to complex. Okay, it's not like a complex to simple, right? Let us try to understand, then elaborate. Okay, fine. Now let us understand pressure exerted by the liquid column. Pressure exerted by a liquid column. Children, examination point of view, it's a very important. Very important. And moreover, from this concept, if they want to ask you a question based on the application, definitely they must choose this topic only. Okay, fine. So children, let us understand. Fine. So let us consider a vessel, that is a container. Fine. And in which some liquid is taken. and the liquid has density, that is rho. Rho is the density. So some children, it's not a p children, it's a rho. This is rho. How to write RH, how to spell rho? Let me try in Hindi also. This is how you have to spell. If somebody is there with Telugu, rho. Don't expect it in any other language. Okay, fine. So rho. What is rho, children? It is a density of the liquid. So children, in this vessel, a liquid is taken whose density is rho, and let us say xy is a free surface. And children, and one more very important thing. This water is at rest, stationary liquid it is. Means it's not like a water which is flowing as like a river. No, it's not like that. Okay, here the water is at rest. Water is at rest. Now, here is a point. Let us say here is a point where we need to calculate the pressure. Let us say this is a point A. Let us say some point P or something. Already rho is there, you know. Again, we may get confused. Some come on, M. Okay, M is a point. Still now, around this M, you know, let us imagine a surface. Surface A with area A. Clear? Now, this point, children, is at a depth of H. This point is at a depth of H. This is very important to understand, children. Very, very, very important. So, in this entire discussion, children, H means we will treat it as a depth only. Please don't treat it as a height. It is a depth from its free surface. Okay, the one particular point M is chosen at a depth of H from its free surface xy. So here around this we assumed a area, surface area with A. Okay, fine. Now the point is that how much pressure will act on this and who will exert the pressure? Who will exert the pressure? Still obviously the water which is above this surface, right? From till here, from its free surface, this entire liquid will exert pressure due to its weight. Yes, due to its weight. So means what here? This entire, this one from here. This entire liquid column. This is very important to understand, children. So from here to here. Am I clear? So this entire liquid, whatever is taken here, entire liquid exert pressure. So that we are going to calculate now. Am I clear? Fine. Now, so this is area. Of course, it seems to be like a cylinder, right? Yes. Water column. This is called actually water column. Children, there is no any shape in that water. Just we are assuming, and now we are going to calculate the pressure exerted by this water column at this point. Clear? Fine. So, children, before that, first, if you want to calculate the pressure, we must know the force acting. Force means in this case, the weight of the liquid column. Okay, first. So, let us write here. Let us take weight. So, here, children, weight is nothing but what? mg. Okay. Children, mass is equal to what? Mass is equal to, we know that density is equal to mass by volume. Obviously, mass is equal to density into volume. This let us put here. This will be density into volume into g. G is what? Acceleration due to gravity. Okay, fine. But how to volume? Volume of what, children? Volume of PQRS cylinder. Volume of what? PQRS. Why we are taking PQRS only? Because we are going to calculate the pressure exerted by this liquid column only. Clear? Fine. So, density into, but how to calculate the volume, children? Yes, we have area A, height H, that is area into H will give you the volume. Okay. So, this will give you what? Area means, let me write here, V is equal to area into H. So, that we am writing here G. Is that clear? Fine. So, children, but don't you think that the weight is nothing but the force? Yes. So, this I can write. You can write as a thrust or, you know, anything is okay. Thrust or force. No problem at all. Let us say it's equation 1. Now children, we know that pressure is equal to, our intention is that only, finally we need to calculate pressure. Pressure is equal to thrust per area. Thrust per area. Clear? Fine. So how much we got thrust? Rho A H G. Let us substitute here. Rho A H G by area is A cancel. So pressure P is equal to, we got, let us write in order, H rho G. Children, this is what actually we are expecting to calculate. P is equal to H rho G. So which means what? Pressure exerted by a liquid column is P is equal to, children, H rho G. H rho G, which is very important. Very important. Children, here the one important surprising which you can notice is that, can you find any term related to the area of the the bottom of the vessel in which it is taken? No. So which means what here? The pressure exerted by the liquid column is independent of the area. This is very important. Independent of area only. Okay, fine. So this is pressure exerted by a liquid column. Here means pressure exerted by a liquid column depend on three factors, children. That is depth of the liquid from its free surface, density of the liquid, acceleration due to gravity. Just you copy it, we'll discuss in detail. So factors affecting the pressure at a point. At a point means where that point, sir? Of course, inside a liquid, obviously. Children, it's very important to understand. So on which factors does the pressure exerted by the liquid column or inside of a liquid at a point depend? Or else we can say factors affecting. Okay, means on what base we can explain whether pressure is more or less, in which case pressure is more, in which case pressure is less. So these points are very important to understand. So children, let us recall once again what are the expression which we got just before. What is that expression, children? That is P is equal to H rho G. H, children, this is very important to understand. Very important. P is equal to H rho G. Okay, fine. Let us see that first point here. So, your children here, this is the very important thing is that here depth of the liquid column. Very important. Liquid column. So how to understand this? So children, let me consider a vessel. Are you able to see this? Let me check. Yeah, you can. So children, here, look at here. Let's say it is a liquid column. Okay. And here a point A is taken. Okay. Here point B is taken. Children, as it is the same liquid at a point A and at a point B. Okay, now. So obviously the density will be same. And as we are performing at the same place, G value also remains constant. But what makes the difference? The depth actually. If you can see, the depth is a matter here. Children, this is at a depth of H1, let us say HA. And this depth is HB. Children, it is noticed that very clearly. It is noticed that let us say the pressure at a point A is PA, the pressure at a point B is PB. And it is experimentally noticed that pressure at a point B is greater than pressure at a point A. Since the depth is more at a point B than at point A. So with this we can conclude that, children, pressure increases with the depth. I mean what? More deeper you can go, more is the pressure exerted. Less is a deeper, less is the pressure exerted. Which means what here? The pressure exerted by the liquid column is directly proportional to the depth of the liquid from its free surface. Children, don't misunderstand, it is not height actually. Depth, from where we have to measure? From free surface we have to measure. Don't measure from bottom. No, that is wrong. We have to measure from free surface. So pressure exerted by the liquid is directly proportional to the depth of the point. More the depth, more the pressure. Less the depth, less the pressure. Okay, fine. Now, second point is that density of the liquid. It also depends on the density of the liquid. Density of the liquid here. Density is a matter. Density is a matter. Okay, fine children. So, let us take here two vessels. Okay. In two vessels, two different liquids are taken. Let us take a well-known liquids, and here is, let us say this first, this one is water, and here is kerosene. Chill, in this case, let me take point A, and here is point B. Okay, fine. Children, both are at place at the same depth. Children. Point A and point B, both are at a same depth. As per the previous knowledge, just forget about the second point. When you consider the previous knowledge, where the pressure will be more, children? Yes, you can say that, sir, just we discussed that pressure increases with the depth. Okay, but in this case, the depth is same. Obviously, pressure must be same. Of course, with this knowledge I am talking. Yes, true. But here, density also matter. Now, let us see when density is involved, how the pressure is going to get affected. This is very, very important. Okay, fine, children. So, it is a water and here is a kerosene. Children, experimentally it has been proved that pressure at a point A is greater than pressure at a point B. What makes the difference here? Both are at the same depth, but they differ in the density. Children, we know that density of water is greater than that of kerosene. Which means what? For a given depth, more the density of the liquid, more is the pressure. Less the density of the liquid, less is the pressure. So, we can conclude that pressure exerted by the liquid is directly proportional to the density. Which means what here? More the density, more the pressure, less the density, less the pressure. Some application question, let us see here. As I said that it is a river. One point A is taken at a depth h. Let me write river. Why? Otherwise you won't believe that it is a river, right? Okay, fine. And here is C. Here also a point is taken B at the same depth h. Four options I'll give you. Option A, pressure at a point A is equal to the pressure at a point B. Option B, pressure at a point A is greater than pressure at a point B. Option C, pressure at a point B is greater than at a pressure at point A. D, none of the above, which is most dangerous option, none of the above. Children, come on. So, I repeat a question. Children's examination point is very, very important. This is how actually questions are asked in exam. Okay, so in a river and a sea, we have chosen 2 points. One is in river, another in sea, which are at the same depth. My question is that where the pressure will be more? Okay, rather let us see the application. Which of the following is right? Children, think, pause the video, comment your answer. Come on, means see, it's a why to comment? To increase so that our confidence levels are increased. Yes, we are attempting the question. We are doing, that is the feel what we get actually. Come on children, okay. Come on. Where is the pressure will be more? Which option is right? Do you think that pressure at a point A is equal to pressure at a point B? Or pressure at a point A is greater than pressure at point B? Or pressure at a point B is greater than pressure at point A? Or you think that, sir, there is no option, sir, it's cheating, you did not give answer, option, you mean to say that? Okay, it's up to you. Come on, got it? Let me take a chance. Okay, fine. So, children, the option C is right. So, yes, option C is right. Pressure at point B is more than that of the pressure at point A. What is the reason? Children, of course, again I am telling you, when a depth is same, pressure must be same. When? As long as the liquid is same. Okay. Do you think that here liquid is same? Obviously no. Here is a river water and here is sea water. Definitely they both are differ in their densities. Okay. Fine. So and also it's very clear that children, density of the sea water is greater than that of the density of the river water. As density is more at a given depth, pressure exerted also more only. So what is the conclusion, children, here? At a same depth, the pressure exerted in a sea water is more than that of the river water. Am I clear? Fine. So this is depth of the liquid and the density of the liquid. Fine. Then third factor is what, children? Acceleration due to gravity. So some students are actually, generally in a textbook, an examination point of view, we don't discuss much about how does it depend on the acceleration due to gravity, and it's not required. And even some students, they are getting confused, sir, how to understand this the dependence of pressure exerted the liquid on what we can say acceleration due to gravity. So almost on Earth's surface, the G value will take as the same. Hello, I am not saying it's the same. It varies from pole and equator and all these things. Generally we take. To understand better way, let us take two situations. Children, so here is two surfaces. Let us take here. Okay. Two identical liquid, what we can say vessels are taken. Two identical liquid. Okay. So in these two identical liquids, children, here I consider point A, here point B. Okay. Here let us say the liquids. It is at a depth h only. It is also at a depth h only. Okay, fine. Now the thing is that, children, okay, just forget about the liquids first. By seeing this, yes, as the 2 points are at the same depth, we may come to the conclusion by saying that pressure might be same. I am talking, not exactly same. Okay, children, let us see here. Liquids are taken. What the liquid? Both are, like I say, it's water only, children, in both cases. Hey, again, don't get confused. Sir, is it river water, sea water? No, it's same water. Same water means what? I mean to say, density of the liquid is same. Density of the liquid is same. She'll try to understand. This is a case where the liquid density is same, depth also same. So, as per our previous discussion, pressure must be same at a point A and a point B. Why? Depth is same and density of the liquid also same. Am I right? But children, this is on moon surface and this is on earth surface. This is on earth surface. Yes. Try to understand. Hey, the distance between moon and earth is very less. Am I right? Yes. Okay. It's not that. Okay. So children, now it is a matter in which case pressure will be more. Then we have to recall the concept of force of gravity. Force of gravity, children. It's very, very important. In which case the atoms of the liquid are attracted with a more force. In which case, yes, in earth case only. Earth case. Why? G value is more, children. So here on earth surface, G value is more than that of the moon surface. Then obviously what will happen? In which case liquid will have more weight, children. Obviously earth surface only. For example, children, here let us take the surface area. In both cases, let us say the 10 meters square. Here surface area also 10 meters square. Try to understand 10 meters square. Here the weight of the liquid is, let us take 100 Newton. Let us 600 Newton. 600 Newton. Children, can you guess what is the weight of this liquid on moon surface? 1/6 of this. Obviously, this is going to be 100 Newton only. Children, don't get confused. Here you may get one doubt that, sir, you are taking a liquid with more weight less. No, we are taking the same amount of liquid. But thing is that on moon surface, the weight will be 1/6 of the weight of the on the earth surface. So I repeat once again here, the weight is always 1/6 of the weight of the body, which if you can take on a earth surface. So here pressure will be what, dear children? Weight, that is force, 100 by 10. And here pressure will be what? Pressure at point B, this will be 600 by 10. So this will be 10 Pascal and this will be 60 Pascal. So obviously the pressure at a point B is more than that of the point A. Rather, let us say that pressure exerted more in the case of Earth's surface than that of the moon surface. Why? Because here G value is more, here G value is less. So which means what, children? The pressure exerted also depends on the acceleration due to gravity. How? Proportional to each other. So we also can conclude pressure exerted is directly proportional to the acceleration due to gravity. Acceleration due to gravity. Am I clear with this? Okay. So there are the three factors on which pressure exerted depend. Just copy it. Loss of liquid pressure. Children, let us say first point. Of course, all we discussed is nothing but the factors affecting. If you have idea about that, this will be very, very easy. So what is the first point, dear children? Pressure increases when depth is increased. Very important, children, very important. Okay, now. So pressure increases with the depth. As more depth you go, more the pressure. Less depth you go, less the pressure. That is the first point. Okay, now fine. So now second one, children. If you can take any stationary liquid, for example, children, here is stationary liquid, let us say. Okay, now here I have taken a point A, point B, point C. Now where the pressure will be more? Children, it is noticed that pressure at a point A is equal to pressure at a point B is equal to pressure at a point C. What is the reason? These all are on same horizontal plane. Means all are at the same depth only. All are at the same depth. It's very, very important point. So pressure at all points is same if they are on the same horizontal plane. On the same horizontal plane, the pressure at each and every point will remain same. Okay, fine. Now the third point is that, children, so in any vessel or any just liquid, it's not a vessel. Okay, here is a point is there, some point, children. So at this point, pressure will act in all directions, left or 360 degrees. This pressure will act. It's very, very important. 360 degrees. Okay. So at a point inside a liquid, pressure will act in all directions, or else from all directions the pressure will act at that point. From all directions a pressure will act at that point. Okay, fine. And the fourth important point is that here what we can say, pressure increases with density of the liquid. Means by keeping this point in a mind, if the depth is same in a different liquids, we cannot come to the conclusions by saying that pressure is same. No, it also matters the density of the liquid. Okay, so here though the depth is same, in a different liquids pressure will be different. If the density is more, if the density of the particular liquid is more, obviously pressure exerted will be more. If the density of the liquid is less, pressure exerted by that particular liquid also less. Okay, fine. And one more important point is that liquids can seek its own level, which means what, children? See, if you can take, you can look at the diagram also. So you can take a liquid in a different, what we can say, in a vessels with the different shapes. But still you can notice that in all cases, the height, I think that the level is adjusted. So which means what? Every liquid can seek its own level. So these are the laws of liquid pressure. Now children, we are arriving to the very important thing is that consequences of liquid pressure. Consequence of liquid pressure. So 101% definitely there will be a question based on this topic. Definitely. Okay, fine. Consequences of liquid pressure. So the first point, children, it's a direct one. It is very easy to understand. So if you can notice the walls of the dam, dear children, so they are made thicker at the bottom. But the point is that why the walls of the dam made thicker at the bottom? Children, can you guess why they are made at the bottom of the, what we can say, bottom of the wall only? Can you guess? If you know the answer, pause the video, you can comment your answer. Okay, na? Why the walls of the dam made thicker at the bottom only? Okay, chalo, let us discuss. The first one is fine. So for this, let us take a, look at it, children. So let us think. Here is a dam. You have to accept it. Okay, fine. Children, let us see at this point A, and here let us observe this bottom. Let us say B. Children, if you can see here, where the thickness is more, yes, at the bottom the thickness is more than that of the top. The point is that only. Why they are made thicker at the bottom than that of the top? So it's very clear that you tell me first of all, in this given liquid, where the pressure will be more? Yes, we have discussed that as the pressure increases, the depth increases, pressure also increases. It's very clear that here pressure at a point B is greater than that of the point A, since depth at a point B is greater than the point A. But examination point of how to write. Children, the first point, come on. So if you have a notes, just try to just note on this point. It's very, the order is very important. Children, from top to bottom you have to talk. This is very, very important. Top to bottom, pressure increases. Very important. Top to bottom, pressure increases. First point. And at the bottom of the dam, the pressure will be more. So very huge pressure will be there. To withstand such a huge pressure, they must be made thicker. If not, what will happen? The huge pressure will act on the walls and they'll get damaged. Try to understand. So we are not expecting that. We want to store the water. Yeah. So for that, the walls must be so strong. So strong means it does not depend on the cement what you are going to use. It is not that. Okay, they have to, the walls have to bear that pressure. It happens only when they are made thicker. Okay, 3 points, very simple. Pressure increases with the depth, and at the bottom of the dam, the pressure will be more. So to withstand such a huge, tremendous, horrible pressure, don't write horrible, huge pressure is enough. So huge pressure, they must be made stronger. It happens only when they are made thicker. Okay, it's very important. So how the question will be asked, dear children? Walls of the dam made what we can say thicker at the bottom. Give a reason. And one more thing, you no need to make any diagram in exam. Okay, fine. This is the first application. Second application, let us see here. Children, if you can notice, air bubbles formed at the bottom of the pond. As they are raising, what will happen? They will grow in size. What is the reason? Now we will discuss. So, like this. Yes. So, you have to believe that it is a pond like this. Okay, let us take some. Okay, fine. So, children, let me see. Okay, bit okay. So, let me write it's a pond. Then you will believe. Now you have to believe. What is this? It's pond. Okay, fine. So children, okay, it's not a matter here. What is our intention? The air bubble which is formed. So let us take somewhere some air bubble is formed. Here let us say this air bubble is formed here. When this air bubble is moving towards the surface, what happens? It's in general, it grows in size. So as it is raising, children, it grows in size like this. Okay, na? Obviously, it will be growing in size like this. Okay, na? Okay, it will be growing in size. Okay, fine. Then how to understand this? Let us take here, children. Let me take again once again here one point A and here a point B. Children, can you guess where the pressure will be more? Obviously at the bottom only. Why? The depth is more. So, the pressure at point A is greater than the pressure at point B, since HA is greater than HB. So, children, here low pressure will be there, whereas at the bottom high pressure will be there. Okay. Children, once you can recall a Boyle's law, which usually we'll get in chemistry. According to the Boyle's law, children, here pressure is inversely proportional to the volume. Inversely proportional to the volume, which means what here? More the pressure, less the volume. Less the pressure, more the volume, children. So, can you guess where the pressure will be more? At the bottom. As at the bottom, as the pressure will be more, the volume is less, it's compressed. Okay, now. Whereas here, as the pressure is less, so volume will be more. Then how to understand in a better way? Let me try to explain. So just let me try to put this point in your mind. For example, at the bottom, let us say, so this is, it is pressure will be more, it is compressed more. Try to understand. So what will happen? Size will be, the volume will be less. As it is growing, so as the pressure is decreasing, so it grows in size. Okay, got my point? So here what will happen? At the bottom, pressure is more, so it is compressed like this. So that volume will be less. As it is growing, as the pressure is decreasing, so it grows in size like this. Okay, na? So here is small, as moving, its volume is increasing. Children, I can just, it's very important to understand. At the bottom, pressure will be more, so volume will be less. As it is raising, as the pressure is decreasing, its volume is increasing. Okay, so here, how we should write your examination point of view, the important thing is that from bottom to top, pressure decreases, very important. From bottom to top, pressure decreases, volume increases. So that what will happen? Air bubble grows in size. Okay, fine. This second application. And third application, one more application can be asked. What is that here, children? So, if you can notice, the sea divers are provided with a special protective suit. Why they are provided with a special protective suit? It's very important. Children, if not, what happens, as they are going deeper into the water, pressure means more pressure will exert on their body, then definitely their bodies will get crushed. So to withstand, to bear that pressure at a deeper, what we can say, depth of the sea or oceans, they have to wear that special protective suit. But what is the purpose? The purpose of the protective suit is that it will, it's a compensate the pressure. I mean what? For example, on Earth's surface, what the pressure is exerting in our body, same pressure. It will make sure that same pressure will act on the body also, swimmer body. For example, 1 atm pressure is acting on our body. Yes, though they can go more deeper into the water, same pressure, 1 atm pressure will act. Okay, children. So that is one more important point. And here, an application part also, one more question will be asked. Especially in some special type of fishes will be there, which will be living the deeper of the oceans and seas, where more pressure will be there. So accordingly, their body blood pressure also will get adjusted. So they can survive at that high pressure only. Then what happens when those fishes are brought to the surface of the water, children? What happens? Obviously, you will get surprised. They will die. How? Their body may get burst. The reason is that as they are brought to the surface of the water, children, atmospheric pressure will be very less. But inside of their body, blood will be flowing with so much of pressure. So as so much of pressure difference will be there, the blood from their body will try to come out suddenly. So their body may get burst actually. They may die. Okay. So children, these are the consequences of the liquid pressure. Consequences of the liquid pressure. Okay, children, fine. Once again, let us recall what topic actually we have discussed today. So it's a very simple topic which we discussed: liquid pressure. Pressure exerted by a liquid column. On which factor does it depend, children? 3 factors: depth, density of the liquid, acceleration due to gravity. Then we discuss about the consequence of the liquid pressure, which are very important. Okay children, prepare well. And one more thing children, you have to read the textbook. It's very important. You may attend the number of classes, whatever it may be. You may take a notes when we are listening, whether it's our channel, some other's channel, anything. It's not that you must watch our channel only. It's whatever you like, wherever you can understand, you can go ahead. But the children, whenever you are listening to classes, try to make your own notes. That's very important. See, to understand the concept, you can depend on others, but to prepare, the notes must be yours only. That's very important. So either you will make by seeing the videos, or a notebook is textbook is it's up to you. And one more thing, my suggestion is that you can take some points from these videos, and at any cost you must read the textbook children. That's very important. Whenever you are reading the textbook children, keep a notes beside you, so that the important points you can note down in that, so that during the examination, okay, instead of going for a textbook again, you can refer your notebook, which will give you more clarity, so that you can do the exam very well. Okay children, thank you so much. All the very best.